It is 12:30 a.m. February 1st. This is the second video log. The alum crystal solution has now been in storage for about 16 days. The alum crystals appear similar to the last log on January 18th. There is a layer at the bottom of the vial where the alum crystals are aggregating as the water evaporates. The crystals appear close to the same as last time, maybe a little larger, but it's hard to tell. We have had extremely cold weather outside, but the vial is not stored near the window, so it's unlikely that the temperature outside has had a significant effect on the crystal growth. However, if it is colder in the room, then the water will evaporate even slower, which would result in less crystal growth but more periodicity in the crystals. In terms of calculating the percent yield, the percent yield can be found by dividing the actual yield by the theoretical yield. The actual yield is just the mass of the alum that was produced at the end of the synthesis. The theoretical yield can be found by using stoichiometry for the four chemical equations that we used to make the alum. In the first equation, we had 1 gram of aluminum foil, which translates to 0.037 moles. And then we had 0.05 liters of 4 molar potassium hydroxide, which is 0.2 moles. 0.037 is the limiting reactant. So we had, using stoichiometry, we ended up with 0.037 moles of aqueous aluminum hydroxide. And then when we put that into the second equation, it also is the limiting reactant when it reacts with sulfuric acid, which produces 0.037 moles of aluminum hydroxide precipitate. In the third equation, we have 0.037 moles of aluminum hydroxide precipitate from the second equation, which is then reacted with the remaining sulfuric acid from the second equation, which yields 0.037 moles of aluminum ions. The aluminum ions then react with the potassium ions from the KOH that was in the first equation. Again, aluminum ions are the limiting reactant. It also reacts with sulfate ions to yield 0.037 moles of potassium, of alum. The molar mass of alum is 474.22 grams per mole. When you multiply the molar mass by the moles of alum, we end up with 17.55 grams of alum. And then when we do the percent yield, which is the actual yield divided by theoretical yield, which is 12.7 divided by 17.55, which is 72.36% yield. The discrepancy in the theoretical and actual yield can be due to many factors during the synthesis. Some of the reactions may not have been done to completion, which would lead to less product to be used in the next reaction. In addition, in the fourth reaction, when the ice bath is used to precipitate the crystal alum from the solution, not all of the alum may have been precipitated out, so some of it is lost in filtration.